All right, this is energy, which we just did. Energy, work, and power. So we have a roller coaster, has a mass of 40 kilograms, and we're assuming he starts here at this point, so that's 10 meters off the ground from rest. Okay, so we're gonna figure up energy values at these different points. All right, so at this top point, he's at rest. That means he has all potential energy. We can calculate that using M times G times H. Let's see, his mass is 40. He's at a 10 meter height here, and then G is 9.8. So that's going to give me 40 times 10 times 9.8 is 3,920 joules. Remember, energy is in joules. He has no kinetic energy at that point because he's not moving yet. And remember, total mechanical always equals potential plus kinetic. And that's our quantity that stays conserved. So here we've got 3,920 joules of potential plus 0 joules of kinetic. So 3,920 is my total energy of my system. I'm not going to have more or less than that because energy is conserved. Now that means I can go ahead and fill that value in from all my other points. Handy. Okay, so point B, we're at 5 meters height. That's this point right here. And that's potential energy 40 times 5, because that's my height there, times 9.8. That is going to give me, it's actually going to give me half of what I had before, because I'm at the halfway point in terms of height. So I'm going to have 1,960 joules of energy there. And then I don't have velocity, but I can get kinetic energy because of this relationship right here, potential plus kinetic. So kinetic is going to be mechanical minus potential, which is 3920 minus 1960. That's going to give me 1960 joules. I'm at the halfway point. So here, half of my original potential energy, which is also the total energy of my system, has converted to kinetic. All right, and then point C is at a 7.5 meter height. So that's going to be 40 times 7.5 times 9.8, and that's going to give me 2,940 joules of potential energy. Again, kinetic I'm going to get the same way, mechanical minus potential, so 3920 minus 2940 gives me 980 joules at that point of kinetic energy. So now some of that kinetic I had here has gone back to potential because I'm at a greater height on point C than I was point B, but I'm still moving, so I still have kinetic energy. All right, and then my final point is D, here down at the bottom. So at D I have no height, so I have no potential energy. All my energy is going to be kinetic at that point. It's all converted to kinetic. Okay, and then there's a couple of quick questions here at the bottom on work and power. Remember, work is our force times a displacement. That's also equal to a change in energy. And then power is work divided by time. That's the rate at which we do work. So a crane is lifting a 25 kilogram cart. What is the work done? And they're lifting it to the top of point A on the same roller coaster, so it's a 10 meter height. So when we're lifting, our work is force of gravity times displacement, or M times G times D. Because we're overcoming that force of gravity. That's the work that we're doing. And so that's our force. So we've got a 25 kilogram cart, 9.8 for G, and then 10 meters for D. So our work is going to be 25 times 9.8 times 10 is 2,450. And that's joules. Work is in the same units as energy. They're both joules. If we know it lifts it in 15 seconds, how much power does the crane use? So that's going to be 2450 divided by 15 seconds. 163.3. And power is in watts. Okay, so force is in newtons, work and energy are in joules, power is in watts. Okay, and then we've got one more example. I'm going to let you do that one using the same type of steps as we did in the previous one.